So we have a project with average duration for it. On the x-axis, this is project time. Project time. Average duration is 25 and standard deviation is 2.38. Let's assume these are in weeks. We want to know what is the probability that project time is 30 or less, meaning we can finish the project within 30 weeks of starting it. We will have to use the standard normal table. We know on the z-axis the mean is 0. We should find the z-value for 30. Z-value is x minus mu over sigma, which in this problem will be 30 minus 25 over 2.38, which is 2.10 rounded to 2 decimals. So we need to know what is the probability or area under the curve to the left of this point where z is equal to 2.10. Applying our standard normal table, this is a partial view of the positive z-values. We will find 2.10 to be right over here where 2.1 and 0 the second decimal are displayed. So 0.9821 is the answer. If I come back here, I find out that 0.9821 is the answer to this problem. Okay. You can also similarly compute probability, for example, that x is between, let's say, 28 and 32 weeks, for instance, or any other number. We can also use the information that we have generated about the mean and standard deviation of this project to compute probability of completing, to find out the due date for a project if we wanted to have a 98% service level or any other service level. So essentially in this situation we're looking at what is that x value or due date or completion time that we should promise to our customer so that, let's say, 98% probability, we have a 98% probability that this project can be finished by then. Again, we use the z distribution, mean is 0, but in this case we know we know the z-value that we're looking for, and I want that to be 0.98 area associated with whatever z-value I read from the table. So if I go back to the table and I find 0.98 or an entry here within the table that comes as close to 0.98 as possible, I can see that those numbers are 0.9798 and 0.9803. Well, I want at least a 98% service level, so I should go with this number, and if I follow the entries, I will find that the z-value is 2.06. So coming back to my problem, I have found that z is 2.06. The x is what I'm looking for. Mu I know is 25 and sigma is 2.38. So x is equal to I believe it's 28.9 if I'm not mistaken. I will now show you how to solve this problem with Excel. So in Excel, we want to know what is the probability that, remember the first problem we solved was probability that project can be completed in 30 weeks. So in this case I will use the norm.dist function. It asks me what is the x value. Remember it was 30. Mean is 25, standard deviation is 2.38, and I want a cumulative distribution. So I can put either true or I can put 1. And that's the number that we computed, if you remember. To compute this probability, what is the probability that mean is between, let's say, 28 and 36 weeks? We have to perform the norm dist function twice, so equals norm dist. First, we computed for 36, where mean and standard deviation are inputted, and I say true. And then I subtract from it another norm dist calculation where the lower number, the 28, is computed. And again, the mean and standard deviation are given. I type them in and then I say true. And that's the probability. There's a 10% chance that we can finish the project between 28 and 36 weeks. And to compute the due date for 98% service level, I use the norm inverse, INV function, and I know the probability that I'm looking for is 0.98 for service level, mean is 25, and standard deviation is 2.38. And with that, I get the 29.9, and in the video, in my calculation, I put it as 28.9. So this number is 29.9. If you were to go through the calculations, which is 25 plus 2.06 times 2.38. I was going based on memory and I wrote it wrong. So it is 29.9. Okay, thank you. I hope you found this helpful.